Simulent is an engineering consulting company. We're affiliated with the University of Toronto, in particular the Center for Advanced Coating Technologies at the U of T. We typically do consulting work with very large companies internationally, and also with universities worldwide. We specialize in computational fluid dynamics, and that has to do with both heat transfer and flow, and we can optimize and simulate all types of flow.
Your background personally is
My personal background is computer science. My first job was with Cray Research, when Cray Research was the first supercomputer that was built in the world, actually. And then after it was bought by Silicon Graphics, I was working for Silicon Graphics as a person who would help optimize codes for using the Silicon Graphics high-end machines to do science. The background of Simulent is U of T, and I came to know Professor Javad Mostaghimi through dealing with the U of T. And I came to work for him in 2011 to help develop the business, because being a professor, he's pretty busy. But Silicon Graphics was built to do graphical interfaces to help people develop products using graphics, so that they can do, I guess you might call it, development using CAD models on the Silicon Graphics machine, because Silicon Graphics is a hardware machine. And basically the graphics that was developed at the time was meant for the big film studios in California. But then it became, once the software was developed for doing development and manufacturing, we were able to then design products using the Silicon Graphics machines back then. Simulent uses software from ANSYS to do development and simulation. And ANSYS requires, in some cases, a graphics machine. And there are other graphical packages that we use to show the customer how the product that we're developing would work in his environment. We do develop some of our own software, but that depends on what we'll be doing. For example, like I said, coating technology. We have our own software that would allow you to understand how a product is being coated. We specialize in droplet technology, spray coating, and coating with heated metal. In the thermal coating technology business, metal is actually being melted and sprayed onto a substrate, which takes on to that, almost like welding, except that there's more coating along the surface, and that helps in things like surface hardening, changing the state of the underlying material to make it better. For example, in the Mercedes, they have an aluminum engine, but aluminum wears out at very high heat. And so what we were able to do with them, or what has happened to the engine block, is they're able to to coat the inside of the cylinder head with tungsten carbide to be able to create a very hard surface, so that when the piston goes up and down, it does not destroy the aluminum engine. Most people, when they develop a product, they would tend to do trial and errors. So they build one product, a prototype, and test it out. And if it doesn't work, they build another prototype, and try to test that out as well. That is very expensive. With simulation, you're able to look at the product before it's being built, and it will give you some very good ideas as to what the product would look like and how it would stand up in this environment. Then, after you've developed this model, then you can go forward and build a prototype, knowing that the prototype would work, given that you've already done all the extensive testing on it, all the stress analysis, all the CFD work, all the heat transfer that needs to be happened, depending on the product you're trying to build.